Okay, so can you tell me yesterday we have taken the one example for finding out directional derivative, and there I think so I've given you one phi. So can anybody tell me the value of del phi? Because we took one type of question for finding out that a bar, the vector a bar. So we'll continue with the yesterday's example only. So yesterday's example. So there I think so we calculated del phi, correct? So I just fixed that del phi, and that was at the point 1 minus 1 1, and it was I bar minus z bar, please check, minus 3k bar, correct? So this was your del phi yesterday. I hope that I'm audible to you all. Yes, am I
Yes,
audible? Okay. So this is correct, no? I bar minus a bar minus 3k bar. Yes. So that was the del phi which we calculated yesterday for the point at 1 minus 1 1. Correct. Now we took yesterday the first type of category of question where we have seen that the vector was directly given along the vector. So that vector is provided, and you have to just find it out the unit vector of that vector and then take a dot product of this two, and that gives you the magnitude, correct? So that gives you the directional derivative. So now the second type of question, so continue with that. So this is our second category of question. So it is towards the point, towards the point, towards the point 2 1 minus 1. It is given that towards the point 2 1 minus 1. So what I have is I have the surface somewhere. Okay, so this is your level surface. So that's our phi given, and then we have a point here, say 1 minus 1 1. Okay, 1 minus 1 1. And now towards the point, so towards the point it is say B, so the point B is 2 1 minus 1. So this is your vector A bar, okay? This is your A bar, okay? This is your A bar in this case. So we have here from the point towards the point, okay? From the point, it is towards the given point, towards the given point. So here, A bar is equal to AB bar. How you calculate this? It is position vector of B minus, so this is your B, correct? Minus position vector of A, correct? So what we have here, B is 2 1 minus 1 minus the point is 1 minus 1 1. So we get that as 2 minus 1 is 1. This is 2 and this is minus 2. So therefore, what is A bar? A bar is I bar plus 2Z bar minus 2K bar. And what is A cap for this? So A cap is nothing but you just divide it by its magnitude. So what is our magnitude? It is 1 plus 4 plus 4. That is 1 by 3 times we have I bar plus 2Z bar minus 2K bar. Now in this case, we are interested in calculating the directional derivative. So the directional derivative of phi along this A bar is given by del phi dot A cap. So del phi in this case is I bar minus A bar minus 3K bar dot, it is 1 by 3 times I bar plus 2j bar minus 2k bar. Correct? So that will be 1 by 3 times. You just multiply the component wise, take the dot product. So multiply the coefficient of I bar. So here it is 1, here also 1. So it is 1. Multiply the component of j bar. So minus 1 into 2. So that is minus 2. Then minus 3 into minus 2. So that is plus 6. So we get this as 7 minus 2. That is 5 by 3. So the directional derivative in this case is 5 by 3. Directional derivative is 5 by 3. So this is the second category of question where you have to find it out the directional derivative of this phi. Okay, directional derivative of this phi along this a bar. But then how you get that a bar? So here the fixed point A was already there, correct? So it is given that towards the point, towards the point. So you have to take that from the point towards the point, correct? So that is nothing but your AB bar. AB bar is your A bar. Okay. So here it is not given directly. A bar is not given directly. You have to find it out. Yes, you have to find it out that. Okay. Now we'll move ahead. We'll move ahead and we take the third category of question for finding out the directional derivative. So the third category or the third type here along the direction along the direction normal to the surface normal to the surface x square plus y square plus z square equal to 9 at a point 1 to 2 at a point 1 to 2. Now this is the third variety of question. Okay, so what we have is we have the del phi is what it is along the direction normal to the surface. Now what is the surface? You can see that this is your sphere, correct? So the equation of this sphere is x square plus y square plus z square equal to 9. Now we have this, if you divide it, okay, if you divide it, so this is x-axis, y-axis and z-axis. So where the 1 to 2 will lie, 1 to 2 will be somewhere here, suppose. Okay, the point 1 to 2 is somewhere here. I want to find it out normal to the surface. So this is your A bar. That normal means perpendicular, correct? Tangent means it is nothing but it will be, you know, the difference between tangent and normal, correct? So here, what is your A bar? A bar is nothing but the normal to the surface. Now we have seen that we get the normal to the given surface by using that gradient of phi, correct? Physical interpretation is what? For that grad phi, it is nothing but it gives you normal to the given surface, correct? So what we do is this A bar is nothing but the here to solve this, you consider this function as something like psi. Okay, what we call this as psi. Okay, so what is psi? The equation of the surface. What is that equation? X square plus y square plus z square. Take that 9 on the other side and it becomes minus 9. It becomes minus 9. Correct? So this will be what? X square plus y square plus z square minus 9. X square plus y square plus z square minus 9. Correct? Now we have to find it out normal to this surface. So the normal to this surface psi is given by del psi. Correct? Del psi means what? Gradient of psi. Now what is del psi? Like we have seen del phi. How you write del phi? In place of phi, now you write it down here psi. So it is dabba psi by dabba x, z bar times dabba psi by dabba y, plus k bar times dabba psi by dabba z. And differentiate this equation. Differentiate this equation with respect to x, y, z. So what we get this as? So it is I bar times what is the derivative of this? It is 2x. The derivative of the term is what? 2y. And derivative of this is 2z. Correct? But we have to find it out this at some particular point. So what is this A bar actually? It is del psi. Correct? A bar in this case is what? Del psi. So here we'll calculate this del psi at a point 1 to 2. Correct? At a point 1 to 2. So substitute here x as 1. So when you put x as 1, what is this 2x becomes? It is 2I bar. Put y as 2. So we get 4z bar. Put z as 2. So we get 4k bar. So here a bar is nothing but del psi at a point 1 to 2. And what is that? It is 2I bar plus 4z bar plus 4k bar. Okay. Now what we have to do is to find out the directional derivative. I have to find it out a cap. Correct? So what is our a cap? So a cap is nothing but 2I bar plus 4z bar plus 4k bar divided by under root 4 plus 16 plus 16. That is 32 plus 4, which is 36. That means it is 1 by 6 times. Correct? 2I bar plus 4z bar plus 4k bar. Correct? So what I get this as? A cap as? A cap is, you take out 2 common. So it is 1 by 3 times I bar plus 2z bar plus 2k bar. So I'm just cancelling that value. Correct? Now once I get this a cap, what I have to find it out? The directional derivative. So the directional derivative of phi along this a bar is given by del phi dot a cap. What was del phi? Del phi is I bar minus z bar minus 3k bar. So it is I bar minus z bar minus 3k bar dot. We have this as 1 by 3 times I bar plus 2z bar plus 2k bar. So multiply this. So we get 1 by 3 times. Multiply the coefficient of I bar. It is 1. Coefficient of z bar is minus 1 into 2. So it is minus 2. And coefficient of k bar minus 3 into plus 2. So which is minus 6. So what I get this as minus 8. That is minus 7 by 3. Okay. So the directional derivative in this case is what? It is minus 7 by 3. So this is the third category of question. Okay. So what we have seen the first one is along the vector a bar is already given. Second category type is what? From point towards the point. Correct? And the third category in this case is what? Along the normal to the given surface. Normal to the given surface. So here the surface is given to you. You have to find it out normal to the surface. So you label it as some other function. Okay, so I have labeled it as psi. And then you find it out just gradient of that. That means find it out del psi. and find out at the point 1, 2, 2 because that point is mentioned here. So you have to just write it down at that point 1, 2, 2. Correct? And that way you'll get the answer. That way you will get this answer. Okay, so this is very simple. Very simple. Correct. Everywhere final dot a cap. And that way you get this final answer. Okay. Now moving ahead, the next type. So now the next is the fourth type of variety. Fourth one. Along the tangent, along the tangent to the curve, x is equal to t square, y is equal to t cube plus 1, z is equal to t plus 5 at t equal to 1. Okay. Now this is the next one. This is the next one. So what is the direction? The direction is the tangent to this curve. Okay. So I have a curve. I have a curve. We are representing it by, say, the point P on the curve is x, y, z. Okay. This is your origin. So OP bar is your R bar. Correct. So tangent to this curve. So you have to find it out tangent to this curve, correct? At this point. So this tangent T bar is nothing but your A bar, correct? Tangent T bar in this case is your A bar. So here tangent to the curve is A bar, correct? So this is for your understanding. This is for your understanding. So what I have to do is I have to find it out first of all R bar. So let R bar is say xi bar plus yj bar plus zk bar. Substitute the values of x, y, z. So it is t square I bar plus t cube plus 1 times z bar plus t plus 5 times k bar. How you calculate a tangent? So the tangent is nothing but dr bar by dt. Differentiate this with respect to t. That is your tangent. Correct? So tangent is equal to dr bar by dt. So differentiate this. So it is what? 2t I bar plus 3t square z bar plus k bar. Now I have to find it out tangent at some point t, particular point t. So dr bar by dt at t equal to 1. So this is your a bar. Okay. This is your a bar. So substitute t as 1. So we get 2i bar plus 3j bar plus k bar. Substitute everywhere. T is equal to 1. T is equal to 1. So that is your a bar. Once I get a bar, the job is easy. Just have to find it out a cap for this and then substitute del phi dot a cap. So a cap is equal to 2i bar plus 3j bar plus k bar divided by under root. It's 4 plus 9 plus 1. So that is root 14. So it is 1 by root 14 times 2i bar plus 3j bar plus k bar. So the directional derivative of phi along this a bar is del phi dot a cap. And what is our del phi? It is I bar minus j bar minus 3k bar. So it is I bar minus j bar minus 3k bar dot 1 by root 14 times. This is your a bar for this category of type of question. Correct? So what we get this as, you can take out that 1 by root 14 outside and then multiply coefficient of I bar, j bar and k bar and add it. So it is what 2, then minus 3, minus 3. So it is minus 4 by root 14. Correct? The answer is going to be minus 4 by root 14. So this way we are getting the answer for this variety of questions. So I fixed compulsory 1 5 and we have seen 4 types of questions here. Now we'll move ahead to take the next type of question. Next type of question. So this variety of questions are framed for 2 marks. Okay. So of course the things will be provided and just you have to find it out the tangent. So del phi is provided, find out the tangent, find out a cap, multiply it. So it's very simple to do it for 2 marks, correct? And you'll be able to do these things in 1 minute itself. Okay. The thing is, we are going to check the knowledge. Yes, the difficulty level will be moderate for all the questions. The only thing is you must know how to solve the questions, correct? So one can frame several questions of same category. Now moving ahead, the next question. Next question. If the directional derivative of phi is equal to axy plus byz plus czx at 111 has maximum magnitude 4, maximum magnitude 4 in the direction parallel to x-axis. Find values of ABC. Okay. Now earlier I have given you that the question where one important note that the maximum magnitude of the given scalar point function phi is mod of del phi itself. Correct. Mod of del phi itself. So del phi is the maximum magnitude. And Of course, the direction is nothing but del phi at that point, correct? That is its direction. And the magnitude is given by just taking the mod of that del phi. So what is provided here that it has a maximum magnitude along the, so magnitude is 4, but in the direction parallel to the x-axis. So I have, suppose this is your x-axis, okay, and here this is our line. So this is your del phi at a point 111. Okay, now these two lines are parallel. These two lines are parallel. How you write? It is something like k times something, correct? So what is the unit vector along this x-axis? It is I bar. So what I'm getting here, so here what is given? So here, given that, how you write this? So it is del phi at 111 is equal to what? The magnitude is 4. But the vector, unit vector along x-axis is going to be I bar. So this is given to you, correct? These two lines are parallel, or the two vectors are parallel, correct? So we get this, yes. Now the only thing is we have to solve this. The only thing is we have to solve this. Once we solve this, we get the values of ABCs, correct? We'll get the values of ABCs. So I'll find it out first of all. So phi is what? It is AXY plus BYZ plus CZX. Okay. Find out del phi. Find out del phi here. Del phi is take the derivative with respect to x. So that value is what? AY plus CZ times I bar. Then take the derivative with respect to y. So y is also involved in two expressions here. So it is what? AX plus BZ times A bar. And then take the derivative with respect to z. It is also involved in 2. So Cx times K bar. Now what I have to do is I have to find it out del phi at the point 111. So find out del phi at 111. Substitute x, y, z as 1. So we get a plus c times I bar plus a plus b times z bar plus b plus c times k bar. Now we'll substitute this in the given equation. So substituting in given equation, correct? What is the equation? Del phi at 111 is equal to 4I bar. But what is del phi at 111? It is nothing but a plus c times I bar plus a plus b times z bar plus b plus c times k bar, that is equal to 4I bar. So equate the coefficients, equate component wise, correct? So what we get this as? So a plus c is equal to 4. Second is a plus b is equal to 0 and b plus c is equal to 0. So what I'll do is I have these three equations in three unknowns. So we just take from 3, put b equal to minus c. So we get the second equation in equation 2. So what is equation number 2? So it is a minus c equal to 0. Correct? I'll call this as 4. Now solve 1 and 4. So what I get? A plus c is equal to 4 and a minus c is equal to 0. So subtract this, add it. So we get 2a is equal to 4. So that means A is equal to 2. Once I get A as 2, what is C? C is equal to 2. And what is B? B is equal to minus 2. Correct? So we get these values and you have to search in the options these values, correct? The correct values and tick the answer. So one can frame again several questions for finding out the ABCs. It doesn't mean that every time such a simple expression will be given, but then it's good. Okay, so here it is parallel to x-axis, so we are considering it as 4I bar. It can be parallel to y-axis, it can be parallel to z-axis. That also we can make the changes. And accordingly, you have to solve it, correct? Accordingly, you have to solve this equation. So this is our next type of question. Now the next question of little bit different type. In what direction from the point from the point 2 1 minus 1 is the directional derivative of phi x square y z cube a maximum. What is the magnitude? What is the magnitude of this maximum? So what we have to do in this case, you have to just calculate what is the direction. So just now I've told you that at the same point, okay, del phi at the given point is nothing but the maximum direction vector. And the magnitude you can just calculate it by taking the mod of del phi. So here to find del phi at 2 1 minus 1 and then find its magnitude. Okay, this is the answer of the question. So this is the trick actually for this. So first of all, we'll calculate del phi. It is what? I bar times dabba phi by dabba x plus j bar times dabba phi by dabba y plus k bar times dabba phi by dabba z. So del phi is nothing but I bar times, just take the derivative with respect to x. So 2xyz cube plus z bar times, it will be x square z cube plus k bar times, it is 3x square y z square. And substitute here del phi at a point 2 1 minus 1. Put x as 2, y as 1 and z as minus 1. So when I put it here, so it will be minus 4 I bar, correct? Because minus 1 cube is minus 1. Then we have minus 2 z bar. And the third thing is here it is 3 4s are 12. So that is 12 k bar. Okay, so this is the direction at which we get maximum. Okay, so this is the direction at which the directional derivative is maximum. Correct. Now, what do you find it out? The magnitude of this maximum. The magnitude is nothing but mod of del phi at 2 1 minus 1, which is nothing but under root minus 4 square minus 2 square plus 12 square. So find out that, and that will be the answer. Okay, that will be the answer. Now the next question. Next question. The directional derivative of a given function function f of xy at a point 2 3 in the direction towards the point q at 1 comma minus 1 is root 17, and in a direction towards r, towards the point r minus 2 comma 1 is root 20. The question is find the directional derivative of f of xy at a point p at p 2 comma 3 towards the point s 6 comma 2. Okay, 6 comma 2. Now here actually f of xy is unknown. Whether the function is given, no. Okay. But what they have given, I don't have a function, but the directional derivative at a point P. So this point is nothing but your P. Okay, 2 comma 3. So the first thing is what is given. So here to find f of xy here. Correct. Then only the things are possible. But what is given? The directional derivative dd of f at a point P towards Q is root 7. Correct? And how you get the directional derivative? So the directional derivative is given by is what? Del f dot a cap is given as root 70. Correct? Now what is del f? So here del f, now it's a function of two variables. So it is what? I bar times dabba f by dabba x plus a bar times dabba f by dabba y. It's a function of two variables. So what I get? So this is the first thing, correct? So here a bar is what? PQ bar, which is what? Position vector of P Q, that is 1 minus 1 minus 2, 3. So what I get this as 1 minus 2 minus 1 and minus 1 minus 3, that is minus 4. So A bar is what? A bar is minus I bar minus 4Z bar, correct? So what is A cap? A cap is 1 upon under root. It will be 1 square is 1 and 4 square is 16. That is root 17 times minus I bar minus 4Z bar. I'll call this as equation number 1. So substituting in 1. What I get this as del f. Del f is what? I bar times dabba f by dabba x plus a bar times dabba f by dabba y dot a cap is what? 1 upon root 17 minus I bar minus 4z bar is equal to root 17. Correct? So multiply, take the dot product here. So 1 by root 17 times minus dabba f by dabba x minus 4 times dabba f by dabba y is equal to root 17. So I'm getting that root 17, you take it on the other side. So the equation, we call it as Roman 1. Okay, this is our Roman 1 equation. Similarly, you get Roman 2 equation. Okay, so another thing what is given, and the inner direction towards R is root 20. So the second equation will be P to R, correct? P to R. This is our first equation. The second equation is the directional derivative of f along PR bar is root 20, correct? So that means it is del phi, del f dot, I'll call it as B cap, okay, equal to root 20. So here we call this as equation number 2. And what is R? R is P is 2, 3 and R is minus 2, 1, correct? R is minus 2, 1. So it is PR bar minus 2, 1 minus 2, 3. So what we get this as? It is minus 4 and 1 minus 3 is minus 2. So B bar is what? Minus 4 I bar minus 2 Z bar. Find out B cap for this. So it is 1 upon under root 16 plus 4. And this is minus 4 I bar minus 2 Z bar. So this is B cap is 1 by root 20 minus 4 I bar minus 2 Z bar. I'll not take out that 4 outside. So we'll substituting into okay. So now I'll not write del f. Del f, you know, we have written it earlier. So we get 1 by root 20 times minus 4 dabba f by dabba x minus 2 dabba f by dabba y, and that is equal to root 20 only. Correct? So this equation can be written as minus 4 dabba f by dabba x minus 2 dabba f by dabba y equal to 20. So we just take out here 2, common 2. So that will be minus 2 times dabba by dabba x minus dabba by dabba y. I'll divide it by 2. This is 10. So this is Roman 2. Now solving Roman 1 and 2. Roman 1 and 2. What is 1? 1 is minus dabba by dabba x minus 4 dabba by dabba y equal to 17. So minus dabba by dabba x minus 4 dabba by dabba y equal to 17. And second equation is what? Minus 2 dabba by dabba x minus dabba by dabba y equal to 10. So I'll just multiply the first equation by 2. Okay. So we'll get 2 and this value will be what? It will be 2 4 is the 8. So this is 8 and 17 2s are 34. And now you will subtract this. Okay, so this will get cancelled. And here minus 8 plus 1 is minus 7. This is nothing but 24. Correct? So I get dabba by dabba y as minus of 24 by 7. Correct? And similarly, you calculate now dabba by dabba x from this. So substitute in any of the equation here. So into when I put it minus 2 times dabba by dabba x is equal to 10 plus dabba by dabba y. So it is 10 plus minus 24 by minus 24 by 7. Okay, so dabba by dabba x is what? This is 70 minus 24 by this minus 2 will go here minus 14. Correct? So dabba by dabba x will be this is 6. 46 by 14. When I divide it by 2, minus 23 by 7. Correct? So I have both the values with me. Correct? You have to keep little bit patience and solve this. So here dabba by dabba x is known now. Dabba by dabba y is also known. I hope that you all are solving along with me. If not, please take the screenshots so that you can complete it later on. But do complete all the notes so that you'll understand more from that. Okay. So I just write it down now del f because we are requiring del f. So what is del f? So del f is I bar times dabba by dabba x plus a bar times dabba by dabba y. So del f is what we are getting dabba by dabba x minus 23 by 7 and this is minus 24 by 7. So minus 23 by 7 times I bar minus 24 by 7 times z bar. Okay. Now what I have to find? I have to find the directional derivative of f along what was that? PS, no? We have seen it PS. So directional derivative of phi from P to S. P is 2, 3, S is 6, 2. S is 6, 2. PS bar. So it is 6, 2 minus 2, 3. So that will give you this as 4 minus 1. So I'll call this as say C bar. So C bar is 4I bar minus J bar. So what is the directional derivative? So the directional derivative of F along C bar is del F dot C cap, correct? So del F is known now. And what is that? It is minus 23 by 7 times I bar minus 24 by 7 times J bar dot. Take the magnitude of this. So it is 1 upon 4, 4 is 16 plus 1. So 1 by root 17 times 4I bar minus J bar. Correct. So what I get this as 1 by root 17, I'll just take it out. Multiply the coefficient of I bar. So minus 23 into 4 by 7 plus 24 by 7. So what is this? Can anybody tell me? 23 4 down.
Minus 73 by 7 root 17.
70.
Minus 73 by 7 root 17.
Okay. Okay. Thank you. So it is minus 73 by 7 root 17, and that's your final answer. Is it minus 73? This is minus 92 and 24, no? 68,
minus
no?
16. Yes, ma'am.
You're wrong. Who told me earlier? Answer. Okay.
Me, Rohan.
So please do it carefully, Rohan. So it's minus 68 by 7 root 17. Okay, so that will give you the answer. So even if it is a simple question, but it is the procedure is too long. Okay, so you require some patience also to solve such kind of questions. So here it ends with the category, all category of questions which we have seen it, and they are all based on this directional derivatives. Okay, all are based on directional derivatives. So yesterday we have seen some property based examples based on gradient, and today we have seen yesterday only we started directional derivatives, but we completed with all the things today. Okay, so this completes your one part. Now we'll see in combination all these things while solving the questions based on vector notations. Okay. So moving ahead, now here we are considering gradient of phi, means it is when del is operating scalarly on scalar point function, correct? We are getting a gradient of phi, and it is always normal to the given surface. Now moving ahead.
जब से हुई है शादी आंसू बहा रहा हूँ आफत गले पड़ी है उसको निभा रहा हूँ जब से हुई है शादी आंसू बहा
Who's this? Who joined this link in between? And it was completely different name. So what we'll do is we are going to take now the new thing that when it operates on vector point function. Okay, vector point function. As I said, we are considering only for 3-dimensional space. Whenever it goes for n dimensions, there you are working with tensor analysis, and there in tensor, what we do is we convert everything in terms of spherical polar coordinates or in cylindrical polar coordinates. Okay, so that thing you have to remember. So vector point function, so we are denoting it by f bar, which is f1 I bar plus f2 j bar plus f3 k bar, where f1, f2 and f3 are the functions of x, y, z respectively. So when this del operates on this f bar scalarly, that means you get a scalar quantity out of this, correct? So that means dot product. So it gives you the new thing which is called as divergence of f bar, and it is used for calculating the electric flux. Okay. Divergence of f bar. What will be this now? So when this del dot f bar is 0, f bar is called as solenoidal. Okay, please remember this. This is very important. When this del dot f bar is 0, f bar is called as solenoidal. Now we'll calculate this del dot f bar. What is our del dot f bar here? Now del is nothing but I bar times dabba by dabba x plus a bar times dabba by dabba y plus k bar times dabba by dabba z dot f bar is nothing but f1 I bar plus f2 j bar plus f3 k bar. Correct? So what will happen is this operator gets operated on the components, correct? In dot product, what we do is we multiply, no? The coefficient of I bar, coefficient of j bar, coefficient of k bar. Now one of them here is an operator. It's a partial order derivative. So that will get operated with this on f1. So what I get this as? So dabba f1 by dabba x. Second is what? Dabba f2 by dabba y. And thirdly, we get dabba f3 by dabba z. So you can see that it gets operated on f1. We'll take the derivative of f1 partially with respect to x. Similarly with respect to y, with respect to z. So this is our divergence of f bar. This is our divergence of f bar. Now we know that dot product is always commutative, correct? We know that a bar dot b bar is same as b bar dot a bar. So in this case, whether del dot f bar is same as a bar dot del, correct? That I have to check. So what we do is we take now f bar dot del. F bar dot del. So f bar is what? f1 I bar, f2 j bar plus f3 k bar dot, what is del? I bar times dabba by dabba x plus a bar times dabba by dabba y plus k bar times dabba by dabba z. Now here you have to always preserve the order as it is. Okay. You have to preserve the order of as it is because one of them is an operator. Correct? So this will be what? F1 times dabba by dabba x plus F2 times dabba by dabba y plus F3 times dabba by dabba z. The way we multiply the dot product. So still we get an operator. Correct? Operator. So that means del dot f bar is not equal to f bar dot del. Okay, so please remember this. Even if the dot product of two vectors is commute, it is commutative, but if one of them is a del operator, then in that case, it never commutes. Okay, it never commutes. Now with this, we'll see tomorrow some more examples based on this because in that session, we'll see the operators, how we are using this operator now. Okay, vector notations. So once you understand that, it is very easy to attempt it in questions. Okay. So now I take the attendance. So roll number 1, number 2, 3,
Present, ma'am.
4,
Present, ma'am.
5, 5, 6,
Present, ma'am.
7, 7 is there, 8,
Present, ma'am.
9,
Present, ma'am.
10, 11, 11 is there, 12, 13, 14, 15,
Present, ma'am.
16,
Present, ma'am.
17,
Present, ma'am.
18,
Present, ma'am.
19,
Present, ma'am.
20,
Present, ma'am.
21, yes, 21, 22, 23, 24,
24 present, ma'am.
25,
25 present, ma'am.
26, 27, 28, 29, 30,
Present, ma'am.
31,
Present, ma'am. 31.
32, 33,
33
34.
present, ma'am.
Okay, 34,
33 present, ma'am.
yes, it's done.
13
34,
also, ma'am.
34 present.
35, 36,
Present, ma'am. 36 present.
37,
37 present, ma'am.
38, 39, 40, 41,
41 present, ma'am.
yes, 42,
42 present, ma'am.
43, 44,
44 present, ma'am.
45,
45 present, ma'am.
46, 47,
47 present, ma'am.
48,
48 present, ma'am.
yes, 49, 50,
Present, ma'am.
51,
Present, ma'am.
52, 53,
Present, ma'am.
54,
Present, ma'am.
55, 56,
Present, ma'am.
57, yes, 57, 58,
Present, ma'am.
59,
Present, ma'am.
60, 61, 62, 63 onwards. Okay, who is left?
Excuse me, ma'am.
Ma'am, I'm 21.
20,
Roll number 11.
21.
Hmm. Who is roll number 11?
From Yuvraj.
Yuvraj. Hmm. Next.
Excuse me, ma'am. 14. 1-4.
14 is
14.
written. Yes.
Okay, thank you, ma'am.
Next.
I'm 15. 15.
15 is also written.
Okay.
Yes, is there anyone who is still left? Can't unmute. Okay. Okay, so meeting you tomorrow. Bye to everyone.
Thank you, ma'am.
Yes.